Alright, this is section 3.3 Piecewise and Power Functions. I'm doing a new way to do your notes rather than the way I have been, just to kind of get used to it, as I want to use this because it allows me to bring up the calculator and some things that the other way didn't allow me to do. So anyway, this is Piecewise and Power Functions in 3.3. So a piecewise function it basically has your domain split up into multiple parts. So it's defined differently on different parts of the domain. Alright, and remember, domain, that's your x's. So that means when we split up the x's, sometimes we get a different way to get the y's. Okay, so example, just something that you've all seen before. Think about the post office. So let's say this is weight, this is cost to mail it. So let's say if it weighs between 0 and 1 ounce, your cost is 44 cents. It's been a while since I've been to the post office. Maybe it's gone up, I don't know. But if it weighs more than an ounce, but up to 2 ounces, then let's say it weighs 64 cents. Alright, and so on and so on and so on. 2 up to 3. It weighs 84 cents. So it's like they're tacking on 20 cents for each additional ounce, or up to an ounce. Okay, now the thing that's different about this than just saying that it's 44 plus 0.2x, like that type of a line, is, well, that's not true here. So if you think that that's what we're doing, we're starting at 44 cents and then we're adding on 20 cents for every additional ounce, that's not technically true. Alright, that's not necessarily true, because if you have something like 0.4, this should say plus 0.44 plus 0.2x, meaning that we're taking the original amount we started with, 44 cents, for just a regular old stamp, and you add to it 0.2x. This is a line. Alright, and this looks like, here's 0.44. Alright, and then there's 1, 2, 3, and so on and so on and so on. And 0.64, 0.84. This looks like this when we have a line. And that's not what we have here. This is not what this is. What we have is what we call a piecewise function, or in this case, a particular type of piecewise function called a step function. And a step function is a piecewise function. So it's price equals literally what we've been saying, 0.44, 0.64, 0.84, and then we could keep going if we wanted to, but just to get the idea, if 0 is less than or equal to x, less than or equal to 1, if 0 is not 0, if 1 is less than x, less than or equal to 2, if 2 is less than x, less than or equal to 3, and so on and so on and so on. What does this look like? This looks like this. Here's your y and x. Here's 1, 2, and 3. Okay? Here's 0.44. Here's 0.64 and 0.84. This looks like this. For 0 all the way up to 1, it costs 0.44. So we've got this horizontal line that goes to there, from there to there. Okay? And now once we move up to bigger than 1 but less than 2, once we're in this region, it's 0.64. So up here, now we got a open dot here all the way across, and then a closed dot. Alright, and this whole entire region is that region. Alright, it's just one output. There's no x involved with this part. Alright, and then the third part, the 0.84, 2 is less than x is less than or equal to 3. Same thing, we got an open dot here, and then straight across to 3, and then a closed dot above the 3. Okay, so it's not a line. It's important that you understand that what we had on the last slide there was not a line. Alright, just more mathematical examples, just straight up math. The type of stuff you guys are going to see. You will see the post office question in there, but just to give you some more just abstract examples that are not application. So something like f of x equals 5x plus 2 if 0 is less than or equal to x is less than 3. Or f of x equals x cubed, the function x cubed, if x is between 3 and 5. Okay. Now if I'm graphing this, I really don't need anything over here in the negative quadrant. Everything's up here. But just to give me some points, I'm going to use x, and then I'm going to use f of x, input output. Just have a little table over here. Alright, now I'm going to pick some numbers in here. In this first domain, the first part of the domain, 0 up to 3 but not including 3. So I could have 0, 1, 2, but then 3 is not included, so I might need something like 2.99. Okay, and then in the other one I have 3 up to 5, both included. So then I can just use 3, 4, and 5. Alright, when I plug in 0, I have to plug it into here. I plug 0 in here because 0 is not in this region. I don't do this to 0. Okay, I don't cube it. I multiply it by 5 and I add 2. This is what I do to the input if the input is between these two numbers. So I only multiply it by 5 and add 2. So I take 5, I multiply it by 0, I add 2, I get out 2. Alright, so at 0, I got a height of 2. Let me undo that. Because this is going to have to go from, it's going to have to go up in 25s. There's 25, 50, 75, 100, 125, 150. Okay. So there's 100, 150. Alright, just to give a scale on here. So 0, 2 is really teeny tiny down here. You can barely even tell that it's above the origin. Alright, now when I plug in 1, again 1 goes into the top one because it's between 0 and 3. So I plug in 1. 5 times 1 is 5 plus 2 is 7. So we get out 7. So at 1, Plug in 1, I get out 7. So again, just barely any movement off the origin. Alright, plugging in 2, again, 2 still goes into the top one because we're between 0 and 3, so it's going to go in here. Alright, so when I plug in 2, I get 5 times 2 plus 2, which is 10 plus 2, which is 12. Alright, so at 2, I got 12. I'm just now barely able to see that it's above the axis. Alright, then when I plug in 2.99, still that's below 3, so that's still in this region. So I'm going to take 2.99, I'm going to multiply it by 5. I'm going to add 2. And that's going to give me 16.95. Alright, so that's, again, right before we get to 3. We're almost up to that first dash on the vertical axis. So about right there. Now, everything in between there is included, so I can connect those lines all the way up to there. It is a straight line. Alright, but 3 is not included. Okay, it's important we see that's not underlined. So technically at 3 we got an open dot here. Alright, now from 3 to 5 we're cubing it. So when I plug 3 into the function, it gets cubed. So 3 gets cubed, that's 27. When 4 gets cubed, that's 64. And when 5 gets cubed, that's 125. These get big really fast. These are all being cubed because they're in this region, which is the second part here. Alright, so 3 cubed is 27. 4 cubed is 64. That's 75. That's 50. So 64 is kind of right in between these two. Alright, and then 5 cubes, 125. That's this one out here. So it's growing much, much, much more quickly. It's even bending upwards a little bit. Alright, so there's a graph of a piecewise function, just to kind of give you an idea of what's going on here. Okay, we're only defined, this function that we have is only defined between 0 and 5, but we split it up at 3. And this is common to piecewise functions. One gets an open dot, the other one gets a closed dot.